To the video here for lesson number 4. So for lesson number 4, we learned about the definition of a parabola and how the parabola can be shown by what's called the focus and the directrix. So number 1 asks us to draw a parabola given its focus and directrix. So what the focus and directrix do is the parabola itself is an equal distance from both the line and the point. So I know that the vertex is going to be somewhere in the middle of those two, so it's an equal distance. And then all of the other points of the parabola are going to kind of like surround the focus. So this is going to be what we call a concave down or an open down parabola. The other thing I would know about this parabola is the p-value would wind up being negative. Number 2 says derive an equation for a parabola whose focus is 0, 4, and directrix is the x-axis. The x-axis has the equation y equals 0, just so you know. So if I was to first sketch where the focus was, so that would be 0, 4, and the directrix is, that would be y equals 0. The next thing I need to do is figure out what is the equation or the point of the vertex. I know it's going to open up, so I know the p-value is positive. Well, the distance from each of these has to be the same. So if I go from 0 to 4, I'm going up 4. So if I divide that in half, I'm going to have to go up 2 to get to the vertex. So if I'm at the point 0, 4, and I go down 2 spaces, the vertex of this equation is going to be the point 0, 2. Also, since I'm counting by 2 to get there, the p-value is 2. So now I know the vertex and I know the p-value, so I can plug it into my equation. My equation, remember, is x minus h squared is equal to 4p times y minus k, where h and k are the x and the y value of the vertex. So I'm going to put x minus 0 squared is equal to 4 times 2 times y minus 2. It's an acceptable equation, but let's derive it all the way to be equal to y. X minus nothing is just x, so this becomes x squared. 4 times 2 is 8, y minus 2. Like we did in class, I am not going to distribute the 8. I'm going to divide it away because I just want to get y by itself. That's going to give me some nasty fractions, so I'd rather just have the one fraction to deal with. And then I want to add 2 to the other side. That gives me an equation of y equals 1/8 x squared plus 2. Check it by graphing it. You'll see it does go through the vertex of 0, 2. Number 3 says the directrix of a parabola, 8y minus 24 equals x squared, x plus 2 squared, has the equation of y equals 1. Find the coordinates of the focus. So the first thing I have to do here is figure out what's the vertex of this parabola. So I could do that 2 ways. I could get this equation equal to y, or I could easily just see that this side is factorable, so I could factor out 8. By factoring out 8, I'm seeing, well, the vertex is going to be -2, 3. I also know the p-value because this 8 is equal to 4p, so p must be 2. So if I sketch this graph, right, I have a vertex of -2, 3, so I have y equals 1. I have -2, 3, so that's where my parabola is going to be. That means the focus is going to be inside that parabola. It's going to open up. The other thing is I know it's 2 in distance, so if I'm at -2, 3 and I go up 2 more, I now know the focus is going to become -2, 5. There are other ways of doing this, but this, I think, is the easiest way. Number 4 says, label the focus and the directrix in a diagram and then derive the equation. So here's the focus, here's the directrix. I notice there's a distance of 1 here, so p is 1. I see the vertex is the coordinate of 1, 2. So if the vertex is 1, 2, and the p-value is 1, I can say x minus 1 squared is equal to 4 times 1 times y minus 2. I'm just plugging back into that formula again I had you write down in your book. So then this becomes x minus 1 squared is equal to 4 times y minus 2. And I know you want to distribute that 4, but we don't want to. It makes it easier to just divide it away. So I have 1/4 x minus 1 squared is equal to y minus 2. Add 2 to both sides, and I get my y equals 1/4 x minus 1 squared plus 2 equation. There's my equation. I don't have to do anything else. Number 5 says find an equation that is equidistant from the set of 0.43 and y equals 3. This is just a fancy way of saying find the equation of a parabola. I'll spell it right this time, unlike how I did in first period accelerated today. So if we know the vertex, or we can find the vertex, so we have y equals 5, we have 4, 3 as the focus. So that means the vertex has to be in between those, and the parabola has to surround the focus. So it's going to be an open down parabola, meaning my p-value is going to be negative. So if I'm going from 3 to 5, that's a difference of 2. So this point must be 4, 4. So I'll go up 1 and then go up 1 more. That's right in the middle. So I know the vertex is 4, 4. I know the p-value is just 1. So I can plug it all in. So now I have x minus the x value of the vertex squared equals 4 times 1 times y minus the y value of the vertex. Just so happens that the x value and the y value are the same here. So I have x minus 4 squared is equal to 4 times y minus 4. Again, divide away the 4. Don't be tempted to distribute it. So this becomes 1/4 x minus 4 squared equals y minus 4. Add the 4 to the other side. And we get y is equal to 1/4 x minus 4 squared plus 4. But I made a mistake, right? What is my mistake? I forgot that the p-value was negative because it opened down. So if I graph this, I would see it will be an open up parabola, which for me would be a red flag that I messed something up. So if I make these all negatives in here, this becomes a negative 1/4. And then we're all set. So that's one easy way of just checking to make sure that you have the right sign for your p-value, right? I didn't do that on purpose, but it was a happy mistake. It gave me a teachable moment there for you. So hopefully this video helps you with your homework. You'll notice tomorrow's lesson, we're doing more of the same, but we'll start to look at parabolas that are actually going to be sideways, so non-function parabolas. And then we'll go from there, right? Hopefully this video helped. Good luck with your homework, and I'll see you all tomorrow.